Welcome to Copoilt Podcasts. 12,000 years ago, your ancestors made a decision that literally changed everything. They stopped wandering and started planting. That single choice, to grow food instead of just finding it, launched the most dramatic transformation in human history. Today, we're tracing agriculture's incredible journey from those first seeds planted around 7500 BC to AI-powered tractors reducing field labor by 50%. You'll understand how 8 simple crops became the foundation of civilization, why the Fordson tractor was agriculture's iPhone moment, and how gene editing is creating drought-resistant corn that could feed 10 billion people. Let me bring in someone who's been diving deep into this agricultural evolution to help us understand just how wild this transformation has been.
You know what's absolutely mind-blowing? We went from collecting wild grains 104,000 years ago to having autonomous tractors in just over 100 millennia. But the real game changer happened around 9500 BC in the Levant region.
The Levant, that's modern-day Middle East, right? What made that area so special?
Exactly. That's where humans first cultivated what we call the 8 Neolithic founder crops: emmer wheat, einkorn wheat, hulled barley, peas, lentils, bitter vetch, chickpeas, and flax. These 8 crops literally became the foundation of agriculture as we know it.
Wait, just 8 crops? That seems like such a small number to build civilization on.
Right? But here's the thing, agriculture didn't just happen in one place. According to the research, at least 11 separate regions of the Old and New World were involved as independent centers of origin. Rice was domesticated in China by 6200 BC and in West Africa by 1000 BC.
So humans were basically figuring out farming simultaneously across the globe. That's incredible.
And the techniques they developed were surprisingly sophisticated. In prehistoric times, they already had seed conservation, land preparation, crop rotation, and early fertilization using what they called no-thing goes to waste principles.
Hold on, crop rotation in prehistoric times? I thought that was a more modern innovation.
That's what's so fascinating about early farmers. They were incredible problem solvers. They observed patterns in nature and experimented with new ways of obtaining food. By 7500 BC, some groups had completely abandoned nomadic lifestyles for settled farming.
But why make that switch? Hunting and gathering seems like it would be less risky than betting everything on crops.
Great question. As the last ice age ended around 10,000 BC, the climate became more stable and predictable. Plus, growing populations meant hunting and gathering alone couldn't sustain larger groups. Farming was actually the solution to a population crisis.
So necessity really was the mother of invention. But let's fast forward a bit. When did we start seeing the mechanical revolution in farming?
The first big leap was in China during the Warring States period, around 475 to 221 BCE. That's when iron agricultural implements became available to peasants. The earliest iron plough found in northern Henan was this flat V-shaped piece mounted on wooden handles.
Iron plows, that must have been revolutionary for farmers used to wooden tools.
Absolutely. But here's what's really interesting. Cattle-drawn plows didn't appear until the 1st century BCE, and by the end of the Song dynasty in 1279, Chinese agricultural engineering had reached this incredibly high state of development.
But the real mechanization revolution happened much later, right? With steam engines?
Exactly. The first mechanized tractors appeared in the late 19th century, powered by steam engines. They were large, cumbersome, and primarily used for ploughing and threshing. The Case steam engine was one of the most notable early models.
I'm imagining these massive smoking machines rolling across fields. Must have been quite a sight.
Oh, definitely. But the real game changer came with internal combustion engines in the early 20th century. The Fordson tractor, introduced in 1917, was one of the first mass-produced tractors with an internal combustion engine.
The Fordson, that's like the Model T of tractors, isn't it?
Perfect analogy. It played a crucial role in popularizing tractors among farmers. And you know what's beautiful about this? For early 20th century farmers, the tractor wasn't just a machine, it was a lifeline. It meant more time with family, less exhaustion, and the ability to feed a growing nation.
That's such a human way to think about it. We often focus on the technology, but forget about the actual people whose lives were transformed.
Exactly. And the evolution didn't stop there. The development of hydraulic systems in the mid-20th century greatly enhanced tractor functionality. Harry Ferguson's 3-point hitch system revolutionized how implements were attached to tractors.
Now we're getting into some serious engineering. But alongside all this mechanical innovation, there was also a chemical revolution happening, right?
Yes, and this is where things get complicated. Chemical fertilizers play an essential role in enhancing crop productivity and soil fertility. They come in various types: nitrogenous, phosphate, potassium fertilizers, and they've been vital tools for worldwide food safety.
But there's a but coming, isn't there?
There absolutely is. According to research published in Springer, continuous utilization of chemical fertilizers is responsible for the decline of soil organic matter content and a decrease in agricultural soil quality. The overuse hardens soil, reduces fertility, and pollutes air, water, and soil.
So we're talking about a classic short-term gain, long-term problem scenario?
Exactly. The Organic Farming Research Foundation found that all classes of crop protection chemicals adversely affect all major taxa of soil organisms, from bacteria and fungi to earthworms. It's like we're damaging the very foundation of healthy farming.
That's pretty sobering. But I'm guessing this is where biotechnology comes in as a potential solution?
Absolutely. And the numbers here are staggering. Over 60% of new crop varieties in 2025 are developed using advanced gene editing biotechnology. We're talking about CRISPR and next-gen gene editing tools creating drought-resistant corn, pest-resistant rice, and nutrient-enriched wheat.
60%? That's a massive shift. How is this different from older GMO methods?
Great question. Unlike older GMO methods, these precise edits mimic natural mutations, making crops more resilient and acceptable to regulators and consumers. It's like we're accelerating evolution rather than forcing unnatural changes.
That's a fascinating way to think about it. And I assume this technology is helping with climate challenges too?
Definitely. Biotech is helping farmers adapt to harsher climates. Crops engineered for extreme heat, flooding, and saline soils are supporting food production in regions once considered marginal. It's literally expanding where we can grow food.
And then there's the whole AI revolution happening on top of all this, right?
Oh, this is where it gets really exciting. Autonomous tractors can reduce field labor by up to 50%, revolutionizing efficiency in modern agriculture. We're talking about tractors that are intelligent, connected, and capable of revolutionizing farming operations worldwide.
50% reduction in field labor? That's enormous. How does that actually work in practice?
It's all about precision agriculture, leveraging data analytics, satellite imagery, and various sensors to increase crop yields while minimizing environmental impact. AI enables more accurate predictions of soil conditions, disease, pests, and weeds.
So we're basically giving farmers superpowers, the ability to see and predict things they never could before.
That's a perfect way to put it. Embedded AI integrated into agricultural machinery enables autonomous systems for crop monitoring, pest detection, and automated operations. IoT devices provide real-time data for precise field management.
But I imagine there are challenges with all this high-tech farming?
Absolutely. According to Springer Research, major challenges include data collection, data ownership, data privacy, and the huge cost of implementing AI-based setups. There are also concerns about public perception of GMOs and ensuring equitable access for smallholder farmers.
So we're creating this amazing technology, but we need to make sure it doesn't just benefit large corporate farms.
Exactly. And there's another fascinating development: lab-grown proteins. Cellular agriculture is scaling fast in 2025. Lab-grown chicken, beef, and fish are now commercially available in select markets, using less land and water while generating far fewer emissions.
Wait, so we're not just revolutionizing how we grow plants, but how we produce meat too?
Completely. And there are microbial innovations improving soil health with engineered microbes that fix nitrogen, enhance root growth, and suppress crop diseases. Farmers are reducing their dependence on synthetic fertilizers while boosting yields.
So we're coming full circle, using biology to solve the problems that chemicals created?
That's a brilliant observation. It's like we're returning to that ancient wisdom of working with nature rather than against it, but with 21st century tools. The Chinese figured this out over a millennium ago. Their agricultural revolution was biological, not mechanical or chemical.
That's such a powerful insight. So what does all this mean for the future? Where are we headed?
Well, global food demand is projected to rise by about 50% by 2050 as the population approaches 10 billion. By 2030, biotechnology could help feed 10 billion people sustainably. We're already seeing promise in reducing environmental impacts while making farming more resilient and efficient.
10 billion people, that's an incredible challenge. But it sounds like we might actually have the tools to meet it.
We do, but it requires balancing innovation with sustainability. The research emphasizes the necessity of ensuring responsible development and deployment of biotechnological solutions, with collaboration between governments, researchers, and industry stakeholders.
So when you step back from this entire journey, from those first 8 crops in the Levant to AI-powered farms, what's the biggest lesson?
I think it's that agriculture has always been about human ingenuity, solving existential challenges. Whether it was early farmers figuring out crop rotation or modern scientists engineering drought-resistant crops, it's the same fundamental drive to feed people and survive.
And now we're at this incredible inflection point where we have tools our ancestors couldn't even imagine, but we're still solving the same basic problem, how to feed everyone sustainably.
Exactly. The stakes are higher now with climate change and population growth, but the human capacity for innovation remains our greatest asset. We've gone from hand-pounding rice to autonomous tractors in just a few thousand years.
What strikes me most is how this story connects every human being. Whether your ancestors were planting those first crops in the Levant, or you're a farmer today using precision agriculture, you're part of this continuous thread of innovation.
That's beautifully put. And the next chapter is being written right now in labs and fields around the world. Every breakthrough in gene editing, every improvement in AI algorithms, every sustainable farming practice is building toward that goal of feeding 10 billion people.
Here's what I want you to remember from today. That decision your ancestors made 12,000 years ago to stop wandering and start planting, that same innovative spirit is alive today in every autonomous tractor, every gene-edited seed, every sustainable farming practice. The next time you see a farm, remember you're looking at humanity's greatest ongoing experiment, one that started with 8 simple crops and now involves AI, biotechnology, and the audacious goal of feeding 10 billion people sustainably. Thanks for joining us on Copoilt Podcasts.